In this video, we're going to look at graphing quadratics, but this time in vertex form. So in the previous video, we saw standard form, which was our ax squared plus bx plus c. In vertex form, it still is representing a quadratic, but we write it a little bit different. So our vertex form is x minus h squared plus k. And so the reason this form is kind of nice and it's called vertex form is we can actually pull the vertex right out of the problem. So our vertex for this is always in the form of h comma k. All right, so that's always what we're going to end up having. So it's really the opposite of what you see inside of the formula because the subtraction is part of the formula. And then what we have added at the end, that's our y value. So this form is really nice. We don't have to use our negative b over 2a. We can pull out our vertex, make our table, use our calculator if we like, or evaluate by hand, and then graph. Okay. So our first one we have here is, this is again in vertex form. So we can see here, I have my vertex, the opposite of positive 3 is negative 3. My y value is negative 4. So right away, I can pull my vertex out of that problem. So if I go ahead and make my table now, these 5 points, 1, 2, 3, 4. So I have negative 3, 4 is my middle point. I'm going to do the same thing as before. I'm going to pick values above and below. So negative 2, negative 1. Maybe I'll pick this negative 4, negative 5. If I want to do this by hand and put negative 5 in, I could do that. But again, we can use our, if we have a graphing calculator, and if you don't have one, you definitely want to make sure you get one or rent one when school does start, because it does help quite a bit with this. So we don't have to do all the evaluating or learn any patterns or anything. We can go ahead and go hit y equals. I'm going to type it just as I see it. So parenthesis, I have x plus 3. Close the parenthesis, and I'm going to hit the square. And I'm going to hit the subtraction sign. Then I'm going to hit minus 4. And if I want to see the graph, I could hit graph, and I'll see the graph. But what's more handy if we have the graph by hand, I'm going to use the table. So I'm going to do second and graph. I'm going to type in my table. So I see negative 3, negative 4. That's my vertex. That checks out. Well, actually, I'm sorry. I should say negative 4. My problem here. And then I can see that my other values, so I have negative 5, 0, negative 4, negative 3. So I'm going to do 0 and negative 3. I know those values have to reflect or repeat. And then I can go ahead and plot my table, right? So again, really nice feature on your calculator. It'll save you a lot of time. And again, the calculator is only as smart as the person using it. So you still have to make sure you understand the concept of what you're doing. But we can still go ahead now and graph that out. And then I have negative 4, negative 3. My points look good just because my computer is a little goofy, but that's okay. We have negative 3, negative 4. And then it repeats over here. There we go. And then we'd have something that looks like this. Notice it opens upward. It's still the same shape as the ones we've been seeing. If they asked for the axis of symmetry, that's that vertical line through the center. That would be x equals negative 3 for the axis of symmetry. But we didn't have to use our formula at all for this one. We're just going to use our vertex form. For the second one, it's essentially the same exact thing. So if I pull out my vertex, the opposite of 4 is negative 4. This is just a positive 2, so I don't take the opposite of the y, just the opposite of the x, because that's what's in the subtractions part of that formula. I can go ahead and make my table. And knowing that my vertex has to be the middle one, because it's going to be symmetrical, it makes it easier so we know where to start in our table. We build out. And then same thing, we're going to go ahead and type that into our calculator. So you would again do the y equals. And we would have, and then you know you did it correctly because your vertex should pop up in your table. And then I'm going to pick values above and below. So -3, -2, -5, -6. And then I'm just going to do above and below. So -2, we got 1, we got 2, and so forth. We're going to go ahead and plot it. There we go. So -4, 2, -5, 1. And then -3, 1, and -2, 2, and -6, 2. My thing was like a little goofy, but we got it. Okay, so now if we were to go ahead and connect this, a few things to kind of note. So again, it's symmetrical. We have our vertex. In this case, our vertex is our highest point or our maximum. It's the highest point on there. That's not a coincidence, though. You can see our value, our A value that we listed in the vertex form is negative. So anytime that leading coefficient or that A value in vertex form is negative, it's going to open downwards. And then it's going to obviously try to change the shape. So if that was a really big number, it'd make it really narrow. If it was a fraction, make it wider. And then the vertex just tells us where the graph's located. For the next two, it's essentially the same exact thing. We just kind of have some more fractions maybe in there, but same thing. So I can see here that I have my vertex. You can see it's 3, -2. We're going to go ahead and make our table. We're going to go above and below. And then same thing, I can put it in my calculator. That's going to tell me the rest of my values. So x minus 3 squared minus 2. And again, you can check it because your vertex should pop up in your table. And I'm going to pick values above and below. And we'd have 1, 6, 2, 0. And then those values repeat. So that's a good sign. And then we would just go ahead and plot it. So we have 1, 6, 2, 0. Three, -2. And then 4, 0, and 5, 6. So if we go ahead and connect it, so this one does open up. You see that this one looks a little skinnier than the ones we've been seeing, which isn't a coincidence. That A value in front, it's bigger than 1, so it's making it a more narrow graph to look at. And then finally, the last one is the same concept. So vertex form is really nice. I can just pull that vertex right out. The opposite of this would be a 2. Now, if this was a positive, I would make it a negative. So it's just a coincidence that these two are the same. I think the above two had it a little different. Keep the y value the same. And then we would do the same thing. My vertex is going to be my middle. we would go ahead and type it in. And if you have a fraction, you can do this a couple of different ways. So if you're looking at your calculator and you're uncomfortable with the fraction, you can do a few different things. You could write 1 divided by 2 if you like. I know that in class, your honors teacher is probably going to have you do alpha y equals quite a bit. So alpha y equals makes it so you can nicely type in a fraction. So I'll actually write that as, there we go. One too many ones. So we have here 1/2, and then I can just type it in like normal. And then again, you did it correctly when you see that your two twos in there. And you can do a few different things from here. If you're like, I want to graph the fractions, I don't mind graphing 5/2 because I recognize that's 2.5. You can do that. I've had some students in the past that are like, I don't want to work with the fraction, but I do see like the next one I can pick is 4/4, and then I have 6/10. If you want to do that, you could. Or you can graph the fraction. It doesn't, and just, turn it to a decimal. That's completely up to you. Another thing you can do is if you want to type it as 1 divided by 2 in your calculator instead of alpha y equals, you'll end up getting the same exact answer. All of us, we're just picking different points to use. So I did it where if I did the calculator, I just picked the ones that had integers because I know those are easier to graph. But again, you'd get the same graph as I did if you used the other points. So we have here then negative 210, which doesn't fit on here, but I do have here 0, 4. I have here 2, 2. I have here 4, 4. And then 610 goes off the graph. It would be somewhere out here. And you can see this is a little more of a wider graph. If you chose the decimals, like for example, if I chose the 1 5/2, that would be 1 comma 2.5, which would be like right around here. Right here and here. And you would still get the same graph that I did, right? So I just chose different points. But same thing. So it does open up. It's wider because of this 1/2, and we were able to pull the vertex out.